The vast silence beyond Neptune, where sunlight weakens to a pale memory and time itself seems to slow. A small frozen world drifts through darkness. It is distant, ancient, and almost invisible against the endless black. For generations, humanity believed this world was a planet. The ninth, the final marker of our sun's dominion, a lonely guardian at the edge of the known solar system. Its name was Pluto, and for 76 years it belonged to us. This is not simply the story of how Pluto lost its planetary status. This is the story of how our understanding of the universe grew beyond the limits of tradition, emotion, and familiarity. It is the story of discovery colliding with nostalgia, of science challenging memory, and of how the universe reminded us once again that it does not exist to comfort us. When Pluto was discovered in 1930, the universe felt smaller. Galaxies were only just being recognized as islands beyond the Milky Way. Black holes were theoretical curiosities. The idea that planets might orbit other stars was still science fiction. In that era, finding a new planet was like discovering a new continent. Clyde Tombaugh, a young astronomer scanning photographic plates night after night, noticed a tiny dot shifting against the background stars. That motion meant it belonged to our solar system. The announcement sent shockwaves across the world. A new planet had been found, and it captured the public imagination instantly. Pluto was named by an 11-year-old girl. It entered textbooks, classroom diagrams, and childhood mnemonics. It became part of how we learned our place in space. 8 planets felt incomplete without it. Pluto was the underdog, the smallest, the coldest, the farthest, but it was family. Yet from the moment it was discovered, Pluto never quite followed the rules. Its orbit was steeply tilted, slicing through the plane of the solar system like a blade. It followed an elongated path that sometimes brought it closer to the sun than Neptune. It was astonishingly small, smaller than Earth's moon. Its mass was so low that it could never dominate its surroundings. But for decades, these inconsistencies were quietly ignored, because Pluto stood alone, because we had no reason to doubt its status. Because sometimes familiarity feels like certainty. As the 20th century progressed, our tools improved. Telescopes grew sharper, detectors became more sensitive, and humanity's gaze pushed deeper into the cosmic dark. We began to understand how stars are born from collapsing clouds of gas, how galaxies collide and merge over billions of years, how black holes warp space-time itself. Our sun, once thought eternal and unchanging, was revealed as a middle-aged star, burning hydrogen in a delicate balance that will one day fail. Everything we thought was permanent became temporary. Everything we thought was simple became complex. And then we started to truly see the outer solar system. Beyond Neptune lies a vast region called the Kuiper Belt, a cosmic graveyard of ice and rock left over from the formation of the sun 4.6 billion years ago. It stretches billions of kilometers into space, filled with frozen worlds that have barely changed since the dawn of the solar system. For most of human history, this region was invisible, but as technology advanced, objects began to emerge from the darkness. Small at first, then larger. Some with moons, some with atmospheres, some eerily similar to Pluto. Pluto was no longer unique. In 2005, astronomers discovered Eris, a distant object even more massive than Pluto. If Pluto was a planet, then Eris had to be one too. And if Eris was a planet, then dozens, perhaps hundreds of similar objects would also qualify. The solar system would swell with planets overnight. The neat structure we taught children would dissolve into chaos. Science faced a choice. Either expand the definition of a planet endlessly, or redefine what a planet truly is. In 2006, the International Astronomical Union gathered to vote on a new definition. It would reshape textbooks, classrooms, and public memory forever. A planet, they decided, must orbit the sun, be massive enough to become round under its own gravity, and most crucially, have cleared its orbital neighborhood of other debris. Pluto failed the final test. It shares its orbit with countless Kuiper Belt objects. It is not dominant. It is not alone. It is part of something larger. With a single vote, Pluto was reclassified as a dwarf planet. The reaction was immediate and emotional. Headlines screamed. Children protested. Scientists received hate mail. Pluto had been demoted, they said, as if it were a punishment rather than a realization. But science is not a hierarchy of pride. It is a process of understanding. Pluto did not change. Our knowledge did. And what we gained was extraordinary. Pluto was no longer an oddball planet, it became the gateway to an entirely new class of worlds, dwarf planets, ancient survivors from the solar system's birth, objects that preserve the chemical fingerprints of a time before planets fully formed. In studying Pluto, we were no longer studying an exception. We were studying a population. Then in 2015, humanity finally met Pluto face to face. NASA's New Horizons spacecraft, launched nearly a decade earlier, flew past Pluto at unimaginable speed, sending back images that stunned the world. This was not a dead, featureless ice ball. Pluto had mountains of frozen water ice rising like stone. Vast nitrogen glaciers flowed across its surface. A heart-shaped plain glowed softly in the darkness. Its atmosphere shimmered with blue haze layers lit by a distant sun. Pluto was alive with geology, and suddenly its demotion felt irrelevant, because Pluto was not diminished by what we called it. It was elevated by what it revealed. It showed us that even in the coldest, darkest reaches of the solar system, worlds can be dynamic, complex, and beautiful. It reminded us that planets,